Okay, we're still first order differential equations because we've got just a first derivative in these equations, but a little bit different. This is what we're used to. We're simply going, well, look, if y prime is 2x, then y is x squared. Duh, it's just integration. How about we go a bit more setting out? If y prime equals 2x, then if I integrate with respect to x both sides, then the integral of y prime is y, and we're comfortable that the integral of 2x dx is x squared. Oh, that didn't line up very well. So that can just be a question by itself. The integral of 2x with respect to x is this x squared. So that's how we're thinking about it. Okay. So if I've got y prime equals, I'm going to run out of room. Y prime equals 2y. And if I integrate with respect to x, this side's easy. That just goes to y. But that is a challenge. Y is not a constant. It's not a number. And we're integrating with respect to x. Well, how do I integrate a different variable with respect to x? It's just, not doable. Anyway, let's see how we get around that. I find the textbook a little clumsy. I'm sure there's teachers out there that love the textbook way, and then you might get some haters here with what I do, but this is the way I see it, and it's beautiful. So here we go. We've got a first order differential equation because there's a first derivative in there, but I've got a y in there. The way we're going to get around the integrating y with respect to x is I'm going to group that y with the dy. So I'm going to multiply both sides by y, and to get rid of that dx, I'm going to multiply both sides by dx. Now I know it's multiply by, but I'm going to use the dot there. So I've got the y's together and the dx is on the other side. So when I integrate both sides, that's doable. So the integral of 4 with respect to x is just 4x. And I've got a y and a dy together. So what's the integral of y with respect to y? That's the same as going, well, what's the integral of x with respect to x? That would be a half x squared. So this would be 1/2 y squared. So doable, quite simple. So I'm going to get y squared equals 8x plus c. There we go. There's a first order differential equation where we've got a y in the equation instead of an x. That was so much fun. To be clear, we can't subtract or add y. So if I went dy dx and then subtracted my y and left that 4 on the other side, then when I get the dx to the other side, I've got to multiply by dx, which means I'm multiplying everything by dx, which does get me just the dy, but I've got this dx connected on this other side, so that's a bit problematic. So we are going to have to treat that as a whole bracket. So when we get that to the other side, I'm not subtracting it, I'm dividing by it. So it's 1 on, I'm going to leave that dy there, and then I'm going to get this dx to the other side by multiplying it. What's left on that other side? Is it 0? When I divide y plus 4 by y plus 4, I actually get 1, yeah? So when I multiply by dx, I've got a 1 dx. Hopefully you can see that. And then I'm going to integrate both sides. When I integrate both sides, I'm integrating that side with respect to dy and that side with respect to dx. Love it because I've got y's and dy together, and we're looking at that going fantastic. I love logs. That's the natural log of y plus 4, and the integral of 1 with respect to x is just x, and we've got to add the c because we've just integrated. I've still got to get y equals, so I'm going to apply my sock rule. And then get y equals. Let's get rid of that c. So that will be e to the c. E to the c is just c. There we go, we'll be doing a bit more of that. There you go, that's our first foray into first order differential equations where there's a y in the equation.